Hey guys, we are going to start with solving systems by elimination. We're going to do two systems with two unknowns on this video, and then the next video, part 2, is going to be three systems with three unknowns, which is actually what the Algebra 2 standards require. We're going to have a little friend with us today, Zach. Zach! Face only a mother could love. The next two slides are going to be questions from class that we talked about. So I want you to try those, and then I'll meet up with you on the fourth slide. Okay, we're going to work through two examples here. A, I'm going to work with you, and then B, I'd like for you to pause and try on your own. I believe we should have talked about these in class today, but just to recap, what you want to do is add straight down in each column. So the 2x and the x and the y and the negative y and the 5 and the 1. But what you want to try to do is to get one of the variables to cancel. It doesn't matter which one is first, it's just whatever's easiest. So in A, the easiest one to cancel would be the positive y and the negative y, because if I add those straight down, I'd get 0. So what we're going to do is just add that, which cancels. So I would have 2x plus 1x, which is 3x, equal to 5 plus 1, which is 6. And when I divide by 3, in that case, then x is 2. But remember, we do want a full point. All I have right now is the x value. So what I have to do is go back and take my x value of 2 and plug it into one of the two equations. It doesn't matter which one. I like to plug it into the top one just to be consistent. So if I plug 2 in for x, then the top equation would now read this. So it would be 4 plus y. And then in this case I would subtract 4 because it's being added. So therefore y is 1. So the answer to this equation is the point 2, 1. Now you can always check these by plugging x in here and y in here and see if you get 5. But it has to work in both equations. So in this case, if we plug 2 in, we would have 4. 2 times 2 would be 4. Plus, and then the 1 would go in for y, which would be 1, and that is 5, so I know that part of the point is correct. Now I need to plug it into the bottom as well, so that would be, let's see, 2 minus 1, which is 1. So that's just a way to quickly check to make sure that your point is correct. Now I want you to pause the video and you try B on your own, and then come back and watch me work it when you're ready. Okay, hopefully you knew to cancel the x's this time instead of the y's because they match up perfectly. One's positive, one's negative. So when I add straight down, I'll have 5y equals 5. So this would give me y equals 1. Now when you're creating that point, last time we found x first, this time we're finding y first. So be very careful and make sure that you put that in the right spot. That is one thing that you have to watch out for. Okay, let's see, what would show up here? Purple. Okay, so now we're going to take the top equation, and wherever I see y, I'm going to substitute for 1 in this case. So I would put, so it's just all substitution again at this point. And we subtract 3, therefore x is negative 2. So the answer, the solution to B should be negative 2, 1. Now again, you can also go back and check it. If I plug in negative 2 here and 1 here, you just want to make sure you get out 1, and you do. If you plug in negative 2 here, you would have negative of negative 2, which is positive 2, plus 2 times 1, which is 2, which would in fact give you 4. So again, that's just a way to double check. Okay, so now what we want to really look at is what happens when they don't have a positive and a negative that automatically cancel. So in that case, we have to just be smart and manipulate a little bit. You still have a choice. Your choice is either to cancel the x's or the y's first. It doesn't matter which one. So in this case, let's focus on the x's. So if I think about this, canceling these, that means that in this missing space here, has to be a -3 in order for them to cancel. Well, that's no problem. All that means I have to do is take this first equation, multiply the whole thing by -3. So let's rewrite that. It would read, this would be 1 times -3 would be -3x. Then I would do 1 times -3 would be -3y. And then 0 times -3 would just be 0. Okay. The bottom equation we're going to leave the same. We don't need to manipulate that one also. In some questions you do, but in this one we don't. All right, so then we're going to cancel these 3's. Now we can continue. So we cancel the 3 straight down, and we'll have -y equals 1. And so y is -1. Remember, we want y, not -y. Okay, so in our answer, we're going to have our y is -1. I don't know if this color is working out very well for you guys, so I'm going to change it to, let's try red. Okay, so again, now that I have this one equation, ooh, that's bright. Now that I have this one equation, I'm going to take the top, the original x plus y, but where I see y, I'm going to plug in -1. Okay, so that's really just x minus 1 equals 0, so x is 1. All right, so in that case, x is 1. So my answer is, ooh, that doesn't look good up there, 1 and -1. Again, we can plug that into the original. So let's do that in this space. So I would have 1 plus -1. The question is that equal to 0? Yes. Okay, so on the bottom I'd have 3 times 1 plus 2 times -1. The question is that equal to 1? We'd have 3 minus 2, which is 1. The nice thing about this portion of the test is that you will be able to check every answer before you turn it in. Okay, so now what happens when we have those, the ones that we have seen have one solution, meaning there is a point that they intersect at. But we also know that there are different types of solutions, like the no solution and infinitely many solutions. So what we're going to do is look at what happens in that case. So here, let's say I focus in part A, I focus in on the x's, and I say that I want to cancel the x's first. Then in that case, if I think ahead, that means I'm going to have to multiply everything on the top by 2. That would give me a 4x, which is exactly what I want, so it cancels. Okay, so let's rewrite it. We'd have 4x minus 6y equals 6. By the way, this last number to multiply by is generally the mistake students make. So if you know that you're having a mistake, check that, because that's very common. Okay, and then we're going to leave the bottom equation just like it is. All right, so what happens though when we get ready to add straight down is the 4x and the -4x are going to cancel. The -6y and the 6y are going to cancel. So now my x and my y cancel. So I say, oh no, what do I do? Well, that's just 0. No big deal. And it says 0 is equal to 12. Well, is 0 equal to 12? No, it's not. Doesn't matter what planet you're on, 0 is not equal to 12. So that's how you know it in fact was a no solution. And all that means is that these two lines are parallel. So if I were to solve both of them for y equals mx plus b, they would have the same slope. Okay, so let's look at what happens with infinitely many. Again, let's focus in on this x value here. And so same thing, I would multiply by 2 to the top. So when we rewrite it, we'd have 4x minus 6y equals 6. And after I rewrite the bottom equation and leave it just like it is, we have something very similar happen. That happened with the no solution, except once these cancel out, okay, that's the same, but over here my 6 and my -6 also give me 0. So is that true? Is 0 equal to 0? Yes. So what that means is that you have an infinitely many. That means it does not matter what you plug in for. You could plug in anything for x and y. Not anything. There's sets of x and y that you could plug in that will always work. They will always give you the right answer. Okay, so that means you have one of these lines, you graph it, and then the other one is right on top of it. Okay, so that's what but this is what it looks like algebraically. Okay, so just remember those two and you'll be able to find any answer. So now what I want you to do is try B on page 18 and see if your see if your answer matches the graph that you already have. It was graph C on that page, which they intersected at a point, so I want you to make sure that you're getting that point. Okay, and be ready to go over these tomorrow in class. Okay guys, Zach just wants to say bye. Zach, say bye-bye. He's hanging out with me on the porch. We're on the back porch. Zach, say bye. He says bye.